Here we go. We will go through the problems for the graded homework assignment 1, starting with problem 1. A scientific law is one of the 5 following, and you have to choose the right one. And you just go down the list, and I put this on here so you have to think about what's a law, what's a theory, what's a hypothesis, all those things that we talked about and are a little bit more difficult to test on quantitatively. I want you to know you're responsible for these. And the answer here is the last one. A scientific law is a brief statement that summarizes past observations and makes predictions. So it ties everything together that's known. It summarizes the past observations, and it does so in a way that allows us to look to the future and make predictions that can be tested in other experiments. I don't see others that are a problem here. It contains an explanation of observations. The first one, well, that's true too, but it's not sufficient. It doesn't have to contain an explanation. It has to summarize the past observations and make the predictions. And then, of course, cannot be modified, subject to change via legal action, must have a mathematical formula. Some do have mathematical formulas, but it's not required. And of course, the legal is because it's a law, is why that's in a distractor. And then cannot be modified. In fact, laws do sometimes evolve over time. And that's the first question. Continuing on here with question 2, which is Rutherford's gold foil experiment helped prove. So let's think about the gold foil, specifically that experiment. And while a scattering experiment could determine the diameter of a gold atom, this one was not configured to do so. It did not constrain the path of the alpha particles enough to determine the diameter. And it had nothing to do with the charge of electrons. That's a different experiment. It didn't have anything to do with the mass, determining mass. It did, however, determine that the mass of an atom is concentrated in a very small space, and that's because only a very few of those alpha particles scattered directly backwards, and most received a small scattering angle. So the last one, the mass to charge ratio of an electron, again, that's a different experiment. So gold foil experiment was the mass of an atom is concentrated in a very small space. Question number 3. Which of the following represents a hypothesis? Again, now I want you to focus on these concepts of the scientific method. And this one, what constitutes a hypothesis? And the correct answer here is actually this first one. But let's consider these others. First, nitrogen gas is a fairly inert substance. Now, if you reacted nitrogen with a number of substances and saw that it rarely react, that would be an observation. And that's why it's now a bunch of observations could lead to making a hypothesis, but an observation is not a hypothesis. In this particular case, sodium reacts with water to form sodium hydroxide and hydrogen gas. Again, observation. You might watch that happen. Nickel has a silvery sheen, observation. When wood burns, heat is given off, observation. So the hypothesis that would be appropriate here would be when a substance combusts, it combines with air. And one sees that combustion occurs, that's the observation. Well, what's going on in combustion? I hypothesize that it's combining with air, and that's what makes that the proper choice for question 3. Question 4, when 2 elements form 2 different compounds, the masses of element B that combine with 1 gram of element A can be expressed as a ratio of small whole numbers. So this is where when, for example, reactions of CO or decompositions of CO are compared with decompositions of CO2, and when that data is looked at as scaling to be 1 gram of one compound, what the results would show is that you get twice as many, or twice the number of grams per gram for O2. If you had a compound like CO3, you would get 3 times as many. And this is what leads to the idea that these are whole atoms. And this was the law of multiple proportions is what this answer is. The definite proportions is a different thing. You want to take a look at that if you're confused review those, I expect you to know them. So now moving on to question 5. First of all, this is one of these problems that didn't format correctly. So really this is supposed to be X in our isotopic notation. So 28 up there, 14 down there. Now remember, this is the atomic number. Lower left corner, that's the atomic number. This is called the mass number. And what the question asks for is to identify the symbol. That's always done by looking at the atomic number, the number of protons. So if we pull up a periodic table, we find out what has 14, there it is, silicon. Silicon has 14 protons, and therefore we can use that to identify this as silicon right there.